All right, let's dive right into this explainer. Today, we're unpacking something literally mind-bending. We're going to take the entire massive 4.5 billion-year history of our planet and condense it into an incredible thought experiment, something you can physically measure and visualize right now. It's the ultimate story of survival, catastrophe, and evolution, and we're going to walk through it step by step to see exactly how we got here.
To really grasp this, I want you to do something for me. Stretch your arms out as wide as they can possibly go. From the tip of your right middle finger all the way to the tip of your left, that entire span represents 4.5 billion years. On your right hand, you've got a hellscape of molten lava. Your entire torso, that's just a couple billion years of microscopic slime. Believe it or not, actual animals don't even show up until we reach your left wrist. The dinosaurs make their brief, dramatic appearance at your left knuckles, and all of recorded human history, everything we know, every civilization that has ever existed, fits perfectly on the microscopic white tip of your left middle fingernail. It really puts our time here into perspective, doesn't it?
So let's start at the very beginning. Section 1, the molten early Earth, 4.5 billion years ago. If we zoom all the way back to the absolute tip of your right middle finger, the sun is just turning on. It's undergoing nuclear fusion. And in the dusty gas swirling around it, our planet is taking its very first fiery shape. We start as a glowing magma ball. It's incredibly violent. For hundreds of millions of years, this molten sphere is just constantly bombarded by asteroids and comets. But those massive impacts aren't just destructive, they are absolutely crucial, because they're actively delivering water to our eventually cooling planet.
Before it ever cooled down, Earth was what we call a planetesimal, basically a clump of rock and metal just drawn together by gravity. And because it was essentially a giant sphere of liquid lava, all the really heavy stuff, like iron and early gold, literally sank straight down to the center. This sinking action was a total game changer. It formed Earth's inner core, which generated a massive magnetic field. That field acted as an invisible shield, protecting any future life from being completely stripped away by the sun's lethal solar winds.
But hey, before we even get to oceans and underwater vents, Earth had to survive a massive cosmic pileup. About 4.4 billion years ago, a Mars-sized planet named Theia slammed right into our glowing magma home, violently blasting a moon-sized ball of magma into orbit, which, you guessed it, gave us our moon. Eventually, things cooled off. A rocky crust formed, and as temperatures dropped below the boiling point, water condensed to form the very first oceans. Around 4 billion years ago, deep in those brand new oceans, near energy-rich hydrothermal vents, the stage was finally set for biology.
Now, life didn't just appear out of nowhere with a magical spark. It started with pure chemistry. First, you get 6 absolutely crucial elements: carbon, hydrogen, nitrogen, oxygen, sulfur, and phosphorus, mixing in this mineral-rich hot water. They naturally reacted with local ingredients like hydrogen cyanide and hydrogen sulfide. These relentless chemical reactions inevitably constructed the precursors to amino acids, lipids, and RNA. And once that incredibly complex, self-replicating chemistry got going, it was totally unstoppable. Moving along, we hit Section 2, oxygen, ice, and asteroids, about 2.7 billion years ago. So we're moving up towards your right bicep on our physical timeline now. Earth is wildly volatile. The planet's interior was exponentially hotter than it is today, creating a hyper-volcanic world. Deep-sea cracks were literally injecting gold, which had been restocked by asteroid deliveries, into the crust, forging the massive deposits we now find in places like Canada and Western Australia. And while the geology was shifting, so was life. Enter Luca, our last universal common ancestor. Every cactus, every shark, every human, we all share this one microscopic ancestor. But it was Luca's descendants, the cyanobacteria, that really shook things up. They achieved a massive biological milestone by inventing a brand new technology, photosynthesis.
And man, this new biological tech was unbelievably successful. See, the early Earth atmosphere was completely stuffed full of warming methane, but these cyanobacteria, they're multiplying uncontrollably, making oxygen from carbon dioxide. They pumped out so much oxygen that it permanently replaced that methane blanket. Sounds great for us, right? Well, it was actually devastating back then. Losing that methane stripped the Earth of its greenhouse warmth. The whole planet plunged into this massive, frozen snowball Earth phase that lasted hundreds of millions of years.
We call this the Great Oxidation Event, and it was Earth's very first mass extinction. To the original anaerobic microbes that ruled the place, oxygen was literally toxic poison. The vast majority of early life was just utterly wiped out by this atmospheric shift. The tiny percentage that actually survived, they did it by figuring out how to metabolize oxygen, unlocking a super efficient way to generate energy.
And as if freezing over wasn't bad enough, Earth is still a sitting duck in a very hostile solar system. 2 billion years ago, a staggering 20-kilometer-wide asteroid slammed into Vredefort in what is now South Africa. Just to put that into perspective, that is double the size of the asteroid that eventually took out the dinosaurs. Double. It hit with such immense force that it folded the Earth's crust back on itself, burying this massive gold field. But here's the crazy part. That impact released huge amounts of trapped dust and CO2 into the atmosphere, which likely helped Earth finally thaw out of its snowball ice age.
Which brings us to Section 3, the explosion of complex life. This covers the span from your torso down to your left wrist.
As we cross your torso on the timeline, we're talking about ancient supercontinents with names like Columbia and Rodinia. No protective ozone layer, yet so deadly UV radiation is just frying the surface. But safely underwater, life is getting a massive upgrade. Think of it like this. For billions of years, a simple bacterium was basically a studio apartment. DNA, proteins, waste, all just floating around and bumping into each other in one open room. But then, these single-celled microbes started swallowing each other, creating these symbiotic cellular powerhouses we call mitochondria. Suddenly, boom, you have a eukaryote. It's no longer a studio, it's a luxury mansion with specialized rooms, a protective nucleus, and organelles. This massive upgrade is exactly what paved the way for multicellular life to exist. Right around your left wrist on our timeline, evolution just slams on the gas pedal. 530 million years ago, the Cambrian explosion fills the glittering seas with shells, teeth, and armor. It's a biological frenzy. But evolution is a bumpy ride. Fast forward to 444 million years ago, and a supercontinent called Gondwana drifts right over the South Pole. This triggers a massive freeze, locking ocean water up in giant glaciers and setting the stage for absolute disaster.
And I mean disaster. During this Ordovician extinction, a staggering 85% of all species on Earth were completely wiped out. Because so much water froze into those massive glaciers, global sea levels plummeted dramatically. So if you were shallow marine life, like those famous little trilobites, losing the shallow seas meant losing your home entirely.
Eventually, the ice thaws, right? The oceans warm back up, but now they're filled with these terrifying, giant, jawed predators called placoderms. It was a bloodbath. So for early creatures like Tiktaalik, dragging themselves out of the water 375 million years ago, that wasn't some brave exploration of the unknown. It was an escape mission. They literally used their early limbs to crawl away from the monsters hunting them in the water, finding a safe haven in Earth's very first primitive forests.
Next up, Section 4, Dinosaurs and Supercontinents, right at the base of your hand.
So we've reached the base of your left hand. All the continents have smashed together to form the ultimate supercontinent, Pangaea. Picture this, scorching deserts, a single terrifying ocean, giant insects, and these weird transitional mammals called gorgonopsids. But an epic global reboot is right around the corner. We call it the Great Dying, the Permian-Triassic extinction about 252 million years ago. It is the absolute closest life on Earth ever came to absolute zero. A massive volcanic complex known as the Siberian Traps erupted continuously for 1 million years. Just think about that. It pumped unbelievable amounts of CO2 into the air, acidifying the oceans to a point where 96% of marine species and 70% of land animals just vanished.
But from the ashes of the Great Dying, Pangaea split apart. The dry interiors turned into these incredibly lush, steaming tropical archipelagos with zero polar ice caps. It was essentially an all-you-can-eat buffet that fueled the dinosaur boom. We're talking 4-story-tall sauropods that literally shook the ground when they walked. They completely ruled the planet for 160 million years, right up until a 10-kilometer-wide asteroid struck the Yucatan Peninsula 66 million years ago. In a sudden flash of nuclear winter, 75% of all species were obliterated. Not a single land animal over 25 kilograms survived the fallout.
Which brings us to Section 5, Asteroids, Gold, and Mammals. We are now at the last knuckle.
At this last knuckle, with the giant dinosaur overlords out of the picture, our tiny shrew-like mammalian ancestors finally took over. And they moved fast. Within just 30 million years, they rapidly evolved to fill every ecological gap, becoming everything from flying bats to massive toothed whales. Meanwhile, deep underground, some incredible geology was quietly setting the stage for our modern economy.
Take a specific geological event in Nevada during this time. Supervolcanoes were exploding across the landscape. One of them, the Atlanta caldera, blows its top and collapses inward. That sequence of collapse literally shattered the ground below, creating this perfect network of vertical pathways. So deep, ancient gold-rich fluids that were locked miles underground got pushed up through those fractured pathways and settled right near the surface.
And here's why that ancient history directly informs modern exploration. Operations like the Nevada King Project are actively mapping out those 30-million-year-old geological pathways today. They're out in the Great Basin deploying drones, geophysics, and AI data to target that massive 7-kilometer-wide collapsed supervolcano. Because they understand the ancient geology, they can mathematically map out resource deposits. They've already defined over 1 million ounces of oxide gold, and they're constantly confirming those models with new surface hits further and further out. It's a pretty incredible real-world application of Earth's deep history.
Finally, we arrive at Section 6, the era of humanity, the very tip of the fingernail. We've traveled 4.5 billion years to get to the literal absolute edge of your left middle fingernail. Here, just a few million years ago, early hominids like Sahelanthropus and Lucy decided to get off all fours and start walking upright full-time. Fast forward 800,000 years ago, we control fire. 40,000 years ago, Homo sapiens are the last humans standing. And that brings us to the end of this explainer, with one final critical thought. Human civilization, all of our writing, our cities, our agriculture, spans just 5,500 years. On the scale of your outstretched arms, we are literally a microscopic speck of white dust on the edge of your nail. The Earth has survived oceans of molten lava, devastating collisions, toxic methane skies, snowball freezes, and multiple apocalyptic asteroid strikes. The planet has always found a way to reboot. So, the question isn't whether the Earth will endure. It's what are we going to do with our incredibly fragile microscopic sliver of the timeline? Think about it. Thanks for joining me, and as always, keep questioning everything.